In the last video we were considering branching and looping. In particular we were looking at the for next loop, and we're looking at the if statement, and now I'd like to just elaborate a little bit more on the if statement. In particular we're going to look at the else if statement. So I'll just copy that code and move that out of the way, and then go to my VBAlesson and double click and paste that code in there, and let's take a look and see what happens. I'll take the design off. I might as well just run the program first of all and see what happens. It gives me the message box greater than 1. Well, looking at the code you can see that x is 3, but is it true that x is greater than 1? Yes, it is, so we'll definitely get that message box greater than 1. But look at the next line. You see, if is x greater than 2? Yes, it is. So you would maybe expect to get that line as well. Well, you certainly won't get that one because it's not greater than 3, but you might expect to get that. Well, you don't, and the reason is that else if, the way it's constructed, once else if finds something, then it won't look any further. So it's a little bit difficult to understand actually, but once you know what it's actually doing, it's not so bad. Else if, it's a bit like if, and once it's found one, then it's happy. We look at the logical operators. They're fairly, you can just look at them here. We've got two variables here, I equals 1 and j equals 2, and you've got an AND statement. That means that if they're both true, which they are, then you'll get yes is, you can see yes is printed on the top left of the screen in cell 1, 1. Also we've got the OR statement. You can see that I has got the value of 1, but j doesn't have the value of 2, but it doesn't matter. The OR statement says as long as one of those is true, it's fine. We've got the not. Well, here is not I equals 2. Well, that's true that it's not 2, it's actually 1. The way it's written is a little bit maybe clumsy. You could say, you'd like to say really if I is not equal to 2, but that's the way it's written, and that seems to work okay. We'll talk about a do loop now. I'll just introduce the code from another screen actually that I'm working on, and I'll paste that code in there to look at the do loop. First of all, let's just see what it does really. Let's go. Let's just click the button. It prints a series of 10s down there. I'll just delete those for the moment. Now, how does it work? Well, a do and the loop go together, just like for and next. But you have to start off by setting your variable equal to 0, and then you increment it yourself as you go, and then print the value of 10. I'll just do this in single steps. So if I click the button, I'll put a breakpoint there. If I F8, then now, oh, that's good. I can see the value of I as I go down. That's very helpful. And then, so I starts off at 0, but you can see that it's been incremented on this line here and made into 1. So if I just continue down, you can see the value of 10 is being placed onto the screen on the left hand side, and then it continues around F8. It continues around, putting 10 on the screen, incrementing the value of I as we go around, and then finally when it becomes 5 it drops out. I's got the value of 5. Now you might say, well, that's just the same as a for loop that we're doing, and you'd probably be right in this situation that it's identical. In fact, we've got I'll just stop the program, we've got the extra overhead of actually increasing this ourselves, which might be a bit of a nuisance. And then you'll say, well, now there are variations on this do loop. I'll just show you some of those. If you can read those in my book or in my manual, you can see that we can have we've just done the do, which is that, and you can have a do until, just a variation really, and then do while loop around. Subtle differences which you can sort out for yourself. But let's take a look at this bit of code here. What I'm trying to do is to show you why would we use a do loop rather than a for loop. So I'll just paste that code in there, and I'm just going to see what it does for a start. I'm going to Right, I've left the the idea of loop is missing from my code, and let's try that again. Okay, so it prints out the value and it selects the value as it goes along, and what it does is actually goes through all of that text and then finds the first available entry at the bottom. Let's see how it does that. Well, here it says cells 1 select, so I'll single step this. Cells 1 select. Let me just see what that does. I'll do an F8 and it selects the top left cell. Do until is empty. Well, do until is empty, so basically it keeps going while it's got something in it. So when it is empty, that will be that will be a true. Do until it's true. Do until it's empty. So, and now let me just single step that once again. Message box, the active cell tells you what's in there, and then loops around, so it goes back again. So I'll just F8 again, loops around and finds out, it keeps going, you see, until now offset 1. That means offset 1 means just go one cell beneath the active cell here. Right, so now I can just keep doing that and giving the value. By the way, you see how that's got the highlighting around there? That means you can just press the enter key to no, you can't. Is that highlighted? We'll find out. No, it's not. If it is highlighted around there, you can just press the enter key and we'll do it automatically without clicking it. Okay, so it goes around, continues around. Message. Oh yes, it has got the highlighting. You see, now if I press the enter key now, it just makes it disappear instead of clicking on it. Okay, so continue around. Now, once it finds it's empty, now it finds it's empty, so it just finishes up. Now, why am I showing you this? And the answer is to show you the difference between a for loop and a do loop. When a program is running, we call that runtime. And so when this code is actually running, the do loop continues, and it doesn't find out until runtime what it's supposed to be doing and what it's supposed to not be doing. So when it finds an empty cell, it finishes, but it doesn't find out until the program is running. Now that's the difference between this and a for loop. You see, with a for loop, you'll usually say for I equals 1 to 5, and you know how many times you're going to go down. But with a do loop, you don't find out that you should stop until runtime. So that's the difference between them. And you might say, well, which one is being used the more? And in fact, the for loop is the one which is used more than, surprisingly, more than the do loop. But that's the difference between them. You might like to try this exercise at this stage here. We've got a series of numbers down here, and you want to increase them by 20%, i.e. multiply by 1.2. And as well as that, you might want to put the old numbers on the right-hand side. So you'll have one loop, and in that loop you'll increase these by 20%, and at the same time you'll be plonking the numbers over to the other side. Let's take a look at the select case structure. The select case is I'll just copy this code into the button, into here. Now a select case is much like a multiple if statement. Let's see how that works. I'll just run the code for a start and see what happens. There we go. We need to define our variable. We've got to say that dim x as integer. That'll do for the moment. Integer. It could be a variant, but let's see if that works. That's fine. Now what is it? Why is it doing that? Well, let's take a look. It says here, I'll put a breakpoint and run the code. You can see that x has got the value of 0 at the moment because it hasn't been initialized. And now I'll do an F8, and it's now got the value of 7. And where's it going to go now? Well, it's going to go and look at the cases, and if it finds one that's correct, which is 7, it should then do that. So let's see what happens there. Select case x, it looks there, no, yes, and so it will message box out the 7. Now as you can see, it's like a multiple if statement. Here's the select case. It looks quite impressive when you first come across it, but indeed I consider it to be a bit of a glorified menu system. The reason is that
if you use an if statement, well, look at this x here. You can't have something like if x equals 2 or y equals and y equals 3 with select case. So that's a bit of a disadvantage compared to the if statement. So I prefer if and else if, but you can use that as well. It's very useful to go to the help for some of these things. Microsoft Help is brilliant sometimes. If I click on help, so I just highlighted select case and press the F1 key. So if I go to the help, you'll see it's got help on select case, and you can see extra things which I'm not telling you. For example, 1 to 4, and you can do 7 to 9. And look at this, if you're doing greater than something, you have to have an is in there as well, which is a little bit of a nuisance actually, but you can have text as well like that. So you could read through that, and you've got case else and that sort of thing. Right, so to find, to all the bits and pieces. But what's also very helpful with Microsoft Help is that you can use the examples. They speak 1,000 words, literally, they do. Absolutely brilliant. So if you want to try them out, you just paste your code in there. Isn't that great? And you can just try it out yourself. Dim number, that's not very nice. This dim number is a variant, you see, but it should be more specific, an integer, in fact. You can see, you might like to look at the code and say, predict what's going to happen. Well, looking here, you see it's got the value of 8. Well, let me single step it. So I can hope this works. Click that, and then it's got the value of 8. That's fine. If I do a single step, then where is it going to go, do you think? Can you see where it's going to go? Yes, it should go down here. So let's see. It'll try out the case here. No, thank you. And then go here. Yes. Now it's now going to execute the next statement. It hasn't done it yet. But the question is, where is that output going to appear? And the answer is, whenever I see that debug print, I know where it's going to appear. It's in the intermediate window. If I press now Control G, then there's my intermediate window. Now I sometimes call it the debug window because it's useful to find out what's going on with your program, to debug it and fix it up. So when you say debug print, that means it's going to be sent straight to the debug window. Let me see what happens. If I single step that, bingo, you see it outputs straight to the debug window, which is useful. It's like a message. I prefer a message box actually to find out what's going on inside my program. But the advantage of an intermediate window is that you can have more than one thing being output, like from 1 to 9 or something like that, numbers. And but it's a two-way thing as the immediate window as well. For example, you might want to say print something as you print a variable that might be in the program, or another way of saying print, by the way, is this is really old-fashioned stuff from way back, print I and so on. But you can actually set the value of I, which could be a little bit dangerous, but you can set values of your variables from within the program itself. Okay, well that's the select case. Let's see where we are. Select case, and now you can practice examples and so on. What I want to talk about now is well, I wanted to talk about a loop inside a loop. Let's start off first of all by having some numbers. I'll just make them a bit different for the moment, just so we can recognize anything. Now, what I want to do is to message box out each of those numbers. Now, okay, so I'll get rid of this code here. Right, and so I'm going to have a loop looping down to message box out each of these numbers. Okay, so the first thing you might think of is a for loop. So yes, and for I equals 1, 2, how many numbers have we got? We've got 5 of them. And then, before I forget, I'll do a next I. Okay, and obviously we need to dim our I before we go much further. Dim I as integer. Now, by the way, if that comes up like that, if I go integer, you just select enter if you want to accept the integer and start a new line. If you don't want to start a new line, you can press the tab key. Just watch this. I'll press the tab. You see it stays on the same line, but in do we do want to go onto the different line. What we want to do now is to message box out the values. So message box cells. Now what are these cells? You're going down row 1, 2, 3, 4, 5. So that means I'll put in the value of the row, comma, and then it's column 1 every time, you see, and then I'll put in full stop value, and that should message box them out as I go down. Now the other thing that I might want to do is to select them as I go down. So to do that, I'll just try this, and now I didn't copy the full stop, because if I press full stop, no, it normally gives me a ItaliSense, but that's fine. So that'll select the cells as you go down. Let me just try that out. Okay, it selects the value, and then I'll just press enter to keep those going, and it selects the cell and goes down one at a time. So that's all very well. What about, what if I put the numbers across here? I want to go across any old numbers. I'll just put 4 numbers here and then just get rid of these other ones for the moment. What if I want to go that way this time? Well, I'll just move this out of the way. Right, well, basically I want to try use J just for a change. I'm going to change each of these to J for some reason or other, and then okay, now we want to go across, so it's J equals 1 to 4 in fact, and then we've got now this is around the wrong way, you see, because it's always always the first row, and then it's going to be the column number, and I need to do it for that as well. 1, comma J. That's fine, and next J, that should work okay. So as we go across, we just message box out each of the values. Right, but what I want to do now is to have 3 rows of numbers. Any old numbers will do. I'll just change a couple. And then, so what I want to do is to message box out this row, and then this row, and then this row. Well, we've got the code to do it for one row. What I want to do is to have another loop. In fact, the loop is going to be outside of the other loop. I equals 1 to something or other. How many? We're going down 3, you see, so that's 3 rows. So it's for I equals 1 to 3. And before I forget it, I'll put my next I down here. Okay, and I need to also put in dim the value of I before I forget as well. Okay, and I'll actually indent this to make it look a bit more understandable. Okay, now does that work? Well, let's find out. If I just click the button, it goes across. Yes, that's fine. Oh, great. Yes. Oh dear, it's still going on the same line. So, what's happened here? Well, you see, if you look here, it's always going on to cell row 1. Well, we don't want row 1. We want row I. You see, as I changes. So we'll change that to I, and just see first of all if it works. Oh great, that's exactly what we want. Okay, but this is the general idea of a loop inside a loop. You've got your inside loop, which is going across, and your outside loop, which is going down. So for every time you go down, you go across. And that's the concept of a loop inside a loop. It's probably one of the most important concepts in algorithms as loop. When we're doing sorting, for example, if you want to sort this set of numbers, then you'd start off with your loop here, and then you would do a loop through them, and for every time you go through, you do like a loop here, and when you do the next one, you do the loop there. You probably don't know what I'm talking about, but you end up with a loop inside a loop, which is used for sorting, but that's all to come. And that sorting, apparently I'm told that sorting consumes about 50% of computer time, is what computers really are all about, extracting data as well. Okay,
So that's the loop inside the loop. Now you might therefore like to consider an exercise on using the for loop, and let's see if we can find a practical application of that. Well, if you've got a series of numbers, like, and these might be checked numbers, and then you want to what we call reconcile. So what you do, you start off by painting the town red. You can go like this in the format painter, and you've got to find one over here which is the same, and the amount should be the same as well. I should have double clicked my format painter. Okay, and the amount is the same, and so on. Now, so what we want to do is to try and we colour them red. There is a way of doing this actually with conditional formatting in Excel. Well, you know, it's a little bit inflexible. You could actually just do the check numbers using conditional formatting as to the amounts as well. So you've got more flexibility if you're going to be using VBA. But I think what I'll do, I'll just ignore the amounts at the moment and show you. And well, I'll need to just put those back to yeah, and you just pick up that formatting and just paint those as well. Okay, so because you might be able to want to, well, that's what you could do, is actually write a program to do that, you see. So let me just see if this, yes, you see, if I click that button, that will do it. That's the code to do it all about. I'll just give you a sneak view of that code, if I can find it. There it is. There you are. I mean, that's the sort of code that you should be able to write at this stage. It's not an easy exercise actually, but if you can do it, you can consider yourself a fairly good standard at this stage.